So we said we're going to do the bottom-up approach, which means if you give me any node, I should be able to split it into two parts, right? So let's learn that part. But first we'll start with basic sort of plumbing. First, why don't we load this empty cars into Python? So the one way to load it is through importing it, right? So for instance, I can go into generative AI capabilities and say, well, load empty cars data set, right? Data set into, like, let's say from stats models. I know it's in stats models package, stats models package in Python, right? In Python. So let's see if it can do it. Right, so it seems like it can do it. So why don't we see whether it works or not by simply printing its not head but info. So let's run this thing and see what happens. Okay, let it run. Okay, it seems like it was able to load, right? So it loaded 11 columns, and we're going to use cylinders, this column number 1 as our labels, Y, and the other columns here, everything but cylinder, meaning 10 remaining columns, will be used as features which we will be testing as features in the X axis, right? So maybe let's start with creating X and Y coordinates now, right? So we loaded the data set, great. Now we need to create X and Y, right? So how can we do this? So one way to do this would be the following. Maybe we can use generate, we can keep using generate AI. Like, I'll show you one more example, but from there on I will be just typing because I kind of know what to do. So let's do this. Create X data frame, right, from empty cars, so that it has all columns except cylinder, right? Because that will go into the Y, right? So look, it created something, probably correct, right? For Y, it's even easier, right? We'll do empty cars Y. Empty cars, not Y, cylinder. Cylinder, right? So we can, yeah, quickly test it if we want to. Maybe Y and X. I won't keep this because it's just too much printing, right? But basically it seems to work. So very simple code here. So we got our Y's and X's right now. Let's identify how many classes we have, right? Because we will need to keep like, see, when we're calculating, when we start splitting the data sets into a node into the leaves, there will be a bit of an issue sometimes, right? And the issue would be, for instance, we started with this big data set, and when we split it to the left and right, on the left hand side we have only one class. So if we're just calculating the probabilities of classes in this data set and just apply it to only the left hand side, it will not know that there were other classes. So we need to start with basically calculating all the classes, and that's what we will do, extracting. And one way to do it would be the following, right? So we just want to get Y, but we only want unique values. So if we did this, then Y would be all the unique values. So you see it's prompting me to print it. Yeah, sure, why don't we print it? See, it got it, 6, 4, and 8. So it's seems like in an incorrect order, but it doesn't really matter. It can be 4, 6, 8 or whatever. If we like a corrected order, then we could just do it as sorted, right? So let's do it sorted, so that's easier. 4, 6, 8 now. Okay, so we'll keep this in classes. So when we're working with our tree, we'll have the classes pre-calculated for us, right? Now think of this: how can we calculate the frequencies of classes in the main data set, in the total sample? So we know there's 32 instances there, but we want to know how many instances of each class are there. So it's very simple. One way to do it would be this, right? So we have y, and we will say y equals classes, right? So why don't we do this? We'll use comprehension. It's called least comprehension, right? So we will do this. We will be summing. All the y's which are equal to a given class, and the class will come from in classes, right? So what are we doing here? This is called least comprehension. So for C in classes we have 4, 6, and 8. So if we say for C in classes, then there's going to be a loop which will get them one by one, 4, 6, and 8, and it'll be iterating through the list. And while it's iterating, it will be assigning C one of these values, 4, 6, and 8. Now we want to go through the entire. So if we say y equals class 4, then what is going to happen is it will be true for every instance of empty cars here, right? Whenever it is equal to, let's say, 4. So it'll be false, false, true, false, 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 true, and so on, right? But when we say sum on the Boolean values, trues and false, then in Python, trues are ones, will be counted as 1, and false will be counted as 0. So we will know how many ones and zeros we got, and that will be our frequencies, right? So if we run this code, look at this. 4, 6, and 8. What's going on? It's 11, 7, and 14. So we have 11 4s, 7 6s, and 8 14s. Is it true? So let's check 6s, right? So 1, 2, 3, 4, 5. Wait a second. 1, 2, 3, 4, 5, 6. Looks about right? So it's doing it right. Well, I know it's doing it right, but just wanted to show you, right? So this is called a list comprehension. So why don't we just implement it as a lambda, right? So we will do it as follows. So we'll call it. So we want to create a function called as frequencies, and we'll call it lambda. And it will have what parameters? It will have parameters called y and c, right? So this is our lambda, I believe. I will have to say right. So we define this function as lambda, and then now we can call this function, right? We can call it as frequencies y and classes. We don't have to say 0. Why is it saying zeros? Oh, sorry. Classes. Right, so we'll do classes. Works, right? So we now, I first experimented it, created it as just a piece of code, and then I wrapped it into a function, right? So this function will count instances of classes in y, right? So if we give them if we give this function our labels, whatever the labels are in our data set, and the classes, then it will be able to count number of instances, right? Now, if we have this, we should be able to calculate the Gini, right? So remember, in our class here, we said we calculate impurities as follows, right? So I gave this little formula here. We call it impurity, but it really is like, let me just write it Gini impurity. So we it's a Gini impurity. The reason I just wrote it impurity is because this formula for the cost is actually universal, right? It works not only for Gini impurity, but it will also work for Shannon entropy. So to remind you, the Shannon entropy is okay. uh, Scikit-learn is does not make things easier, right? So okay, let's call this log loss entropy, right? So we can use this formula or the Gini impurity, and both can be plugged into the cost. So that's why I wrote it impurity in the beginning, but let's say it's Gini, so we know it's Gini. Okay, right? So let's implement this Gini impurity. Seems very easy, right? It's sum of squared probabilities subtracted from 1. So how can we do that? One way to do it would be as follows, right? So let's keep it as a... So we're building bottom up, right? So we're building basic skills from which we will be building we will be building the whole algorithm, right? So it's from very bottom. And at the very bottom, we want to know how to do Gini, right? So this was frequencies, right? And this was classes. Now, how do we do Gini? So the easiest thing for Gini, I guess, would be the following. So we can do the following. We can sum probability. So the easiest, okay, let's do it maybe not in the best way, but okay, so I'll explain what I mean. So we need to get the sum of all the squared probabilities, right? So how do we do that? Well, we get frequencies. So suppose we're given frequencies. Frequencies, so maybe we will run it like this, right? So we'll say frequencies this way, right? And then we can just supply our frequencies, or maybe we'll just say FR. So we'll supply these FRs, and then FR is divided by sum of all the frequencies. That's how we get the probability, right? So think of this. Well, probabilities are frequencies divided by sum of all frequencies. Okay. Right. One problem here is like what we don't like doing is we seem to be calculating the sum of frequencies several times, but it's okay, right? So probabilities are sum of frequencies, and then our Gini impurity is simply going to be what? It's going to be 1 minus c. It even knows the formula. I didn't even tell it what's the formula. Look, how does it know? Amazing, right? Well, it didn't work. Probabilities, frequencies, right? Because we can't do this for we can't do this for right for the list. So we'll have to modify this thing, and we will modify it as follows. We will say sum, and then we will say frequency divided by sum of all the frequencies, right? And then we want to square it. We should be able to square it. Right? Does this work? Yes, there was an extra. Okay, there was an extra parenthesis, so that should work. Right, so it seems with the, you see, the problem is like I keep using I'm used to using NumPy arrays, but this is a list. So in the list, we'll have to do the comprehension, I guess, list comprehension. So let's do the list comprehension again. Sum of frequencies divided by this guy. Right, so we will sum of frequencies, blah blah. Okay, this is good for f or in frequencies, right? Okay. So what are we doing here? Let's see if it works first, and then right. So there was some frequencies. So there was an extra parenthesis which we are missing here. Okay, this parenthesis matches this guy, and then here we don't need a parenthesis. But we need the parenthesis at the very end. Okay, now it works. So what did we do? We used the list comprehension again the following way. So we got all the frequencies into this object called fr. That's a list of all the frequencies. And then for f in fr, meaning we're going to loop through every f in fr, right? So we will be pulling these frequencies like 11, 7, 14. And then we will be doing the following. We will be dividing the 7 by the sum of all the frequencies, which is like 11 plus 7 plus 14, it's 32, we know. So we will calculate 11 over 32, square it, and then we will create a list of this, 7 over 32, square it, 14 over 32, square it. Then we're summing them all together and subtracting from 1. And that is this Gini impurity formula, right? Now we can wrap this into, again, into a lambda here, right? So we will say the Gini is going to be a function in this case, and we'll make it as a lambda, and it will have parameters, just frequencies, list of frequencies, nothing else. Right, and if we do this, it will run the function, and then for the Gini we will be using frequencies, right? So now notice here, when I say lambda frequencies, I don't really mean these frequencies. It can be anything, right? So to demonstrate this, let me do this. Let's just change this to x. So x is going to be my list of frequencies, right? If I do this, it will still work, right? Because it doesn't really matter what you call this. It's just the name of the parameter, it can be anything. So I'm supplying frequencies into it to calculate this value, right? Right. So I think we have more or less our basic stuff. So now we know a few things. So we created our labels wise, we created X data set, and then we've learned if we have this data set X and Y, they represent our full sample. So we know now how to calculate frequencies of each class and then calculate Gini impurity. So now we're ready actually to start splitting this data set, because what we will do here now is we will be picking different columns in X one by one, and then using the threshold we will be splitting our data set X and Y into X and Y of the left and X and Y of the right. And then we will be able to calculating Gini impurity for Y's on the left and Y's on the right. And we will be able to combine them into this formula to calculate the total cost. And then we'll run it by each column of X and find the best combination.